Thank you guys for being here today. My name is Nico. Sorry about this small delay. As usual, computers don't work as supposed to. All right, so let's start with this presentation. So before we start, let me ask you a question, because I'm sure everyone here somehow know about computers, or at least have some idea. And if you ever are the working computers or study something related to computers, you are the computer person at home, right? Like every time that someone has a question, they will go directly to you. And every time that someone has a problem, they will go to you. Now, I know there's a solution for like 80% of your problems, or at least when your grandmother, your grandfather, your uncle call you and be like, I have a little problem with my computer. There's one solution that fixes 80% of those problems, and that solution is restart, exactly. So number one fix for most of the problems is restarting. Now, when we are talking about computers on an enterprise level, restarting, turns out, is a much complex problem. Imagine we are in a data center. In a data center, there's so many computers. When a computer goes blue screen or a kernel panic, nobody's there to reboot it, right? It's sort of like that philosophy of like a tree falling in the middle of the forest, you know, it's actually if the tree is down or not, because nobody was there to hear it. In this case, it's sort of the same, but like you actually hear it, but like people call to you and complain about like the server being down. And the problem with data center is like, it's one of the worst places you have ever been. I don't know if you have ever been in a data center, but I have been in a couple, and it's cold, there's no place to sit down, like you're standing up all the time, there's a small computer, and it's far, it's usually far, it's like an airport, it's so like far away. It's like going to a hospital in a way, like nobody wants to go there, but every now and then you have to. So the main idea of this presentation will be to discuss BMC, and BMC is sort of like what the different manufacturers thought it would be the solution to this problem. And it actually is the solution to the problem. So this is me, the research I have done with BMC, I have done it myself, but also with my partner, Matthias, which actually doesn't work with us anymore, it's working with Intel now, but you know, I should mention him. Anyways, but before we actually start with the actual BMC, I want to make this a big part of the presentation, which is research. Research is what obviously we have done with BMC, but research is kind of like a novel thing where you're working on information security. So, I mean, I see there's a lot of students in the audience, and obviously when you're a student, you have to concentrate on study and passing grades and all that, but the reality is there is a point where you are working in the security industry, and at some point, you get into a place where you are comfortable with what you have learned. You have learned all the basics. That's the most important part. But once you have learned the basics, it's time to do the next step. And that next step is creating knowledge. The way you create knowledge is by doing research. Obviously, there are different types of research. There's research that like put together different knowledge into one paper, and that's perfect. But in this presentation, we're talking about the research that is novel, that is going like one step farther of your usual knowledge. And that's kind of like my idea for this presentation, is to give you a little concept of like what exactly research means, while talking in this case, but this is a specific case about BMC and the research we have done. So the first thing that research will give you is, apart from start creating knowledge, going to Greenlands, is to start to understand the technology. There's a point where documentations are not good enough, and you have to go deep into the program and deep into something that nobody has ever done it. The way you do that is that you Google and you see like no findings at all. Like after going pages and pages, there's nothing related to your problem. So you have to find another way. So you have to go into a debugger, into a reverse engineer tool to try to see and understand how that thing actually works. And that's part of research. Once you document that, you actually have a full research. The other thing is finding bugs, and that's part of my passion, is finding bugs on software. And that's beautiful, and there's a lot of interesting things when you're finding bugs, and kind of like the focus of this presentation. The other important thing about research is that you are able to show other teams how insecure things are. Obviously, everything is insecure, we know that. But sometimes the decision between two products might rely on which one is more secure than the other. And that is related with research. It's like understanding those products you're about to put into your network and to see which one is better or not. And obviously you can count CVEs, that's some sort of like way, but you can go deeper and try to understand how things were implemented to actually get into your network on your computer. Now, when we're talking about bugs, this is the first thing that came out to everyone, which is 0 days, which is what in one way or the other you're looking for. A 0 day has like many definitions, but my favorite definition is a bug that has not been patched and there's no public knowledge about it. And 0 days are a weird beast. They have like different characteristics. They're not all the same. One of the first most interesting characteristics is the complexity. How complex the vulnerability that you just found is inside the software or the code. Now, in my experience, I have worked with like so many people in the company or friends and other, and I have like find like two different type of like people that find 0 days. There is the person that, and I have a coworker that was like that, is that you will find the most simple bug, but it will be in the most complex place in code. So he will find like right at the end of some protocol where like nobody has ever got into that, he will find the most simple bug. And then I have a friend where they will find a bug right in front of your eyes, like in a place where everyone has looked at, open source. The first thing you will look at will be on that, but he will find the most complex vulnerability at all. And that's the two type of persons. Like somehow you have to go in a sort of complexity, and the reason for that is that if you don't go and find vulnerabilities on complexity places, the faster will actually find for you, and then someone's going to kill it. So if you're looking for a 0 day that's going to last at least a couple of months, you have to go deeper in the code or deeper into your understanding of what's going on to find a vulnerability. The other thing is uniqueness. Obviously, not all vulnerabilities are the same. If a bad class is a new bad class, then nobody will know about it. And yet again, whoever is doing a fuzzer and is trying to model potential vulnerabilities through the fuzzer, they will not be able to find vulnerabilities that you just find. Obviously, the other two are related more to exploitation. Relevance obviously is very important because it's depending on the target you're looking for. It's not the same to be like targeting a web server that some student wrote for college, and the other thing, attacking Apache and finding everything Apache. There's two different things. One is more, well, it could be, it depends on what you're looking for. If you're planning to, if you're trying to hack into a network or do a penetration test into a network, and they're actually using the web server for the college kid, that's perfect. But if you actually are looking for a big target that is running Apache, then like, that's what you have to aim for. And obviously that's more difficult to do. And obviously exploitability is that there's all sorts of vulnerabilities. There are ones that are really hard to exploit. Some of them are like impossible to exploit. So that's something to keep in mind. And finally, one last thing about 0 days is that no matter what, a 0 day is going to die. You know that. Either the software's been updated, or someone find the bug again, or you're actually working on it and someone else, there's a collusion between you finding it, someone finding it, and someone publishing it, and you don't have enough time to prepare it, and so it's dead. So this phrase I think is Latin, which basically means you know it's going to die, you don't know when. And that's going to happen with us, and it's going to happen with vulnerabilities. Now, let me go through my way to do research. And I think it's a way, I mean, it's a methodology. There are multiple methodologies. But my kind of like work this way. The first thing I do when I'm going against a target is I start learning about it. I start reading as much as possible about whatever I'm trying to do. Then I want to set up the environment. I want to make sure what I'm going to be looking for. After like reading a lot of information about it, I need to understand which is going to be my targets and set up an environment to test that. Obviously, the environment is very connected with the tools I'm going to be using because I have to prepare the tools for that environment. It's going to be special dividers, it's going to be my this assembler is going to be someone else's assembler that allows me to attack this specific device that I'm looking for, and then I get into this never-ending loop of learning more and more into reverse engineering, analytically actually code or binary, and at the same time fuzzing. Fuzzing should be something that you are doing all the time, because fuzzing is the computer working nonstop, and we have that. Like every time the computer is idle when you're doing research, you're failing, because the computer should be going and going and going. We're actually reading, we're actually thinking. Your purpose on a research should be like think and read and understand. The computer process will be just being stupid and like throwing bytes and things. Maybe you can make it a little smarter or not. It should be like working nonstop. Even when you have no idea what you're looking for, start by like doing like a very stupid fuzz, and then you can go and do something a little bit smarter. But in the meantime, like we're still working, the computer is working at the same time as you. And this is something like super important. So when we start doing this research related to BMC, what happened is that one of our biggest clients, a huge financial industry company that is all around the world, told us that they have BMCs on the network. Have like around 20,000 of those. I'm going to explain what a BMC is, but continue with me. So they have like 20,000 of those, and they were like worried about the security of these devices. Now, when a client contacts you, the first thing you have to do is, okay, I'm going to do the research, but it's going to take that amount of time. So what happened with this triangle is that, and this is not just for clients, it's for like any sort of research, your currency is time. You have to know how much time you have in order to see how you invested on this research. The other important factor is scoping. You need to understand what you want to attack and what's the requirements for your attack. Like, do you want to do an authentication attack on this target? That target has to support many different versions. This is very important because when you are actually doing the test, you are looking exactly for that. And finally, the objective. What exactly is going to be what you're going to look for? It's going to be something that allows you to get into the machine, something that allows you to get information, do a leak of information on the server, etc., etc. These are three factors that, before you even start, you have to think about and start deciding as you go on. But if you plan ahead, it's way better than you just throw yourself. Anyway, let's now talk about the actual BMCs. So, I'm not going to spell the acronym on BMC because I can't recall what it was, like something like baseband, management controller, or something. I think that's what it means. So basically, BMCs, as I said before, is a response from different manufacturers to the idea of how you're going to reboot a machine remotely on a data center. And what they did is basically, they add a micro in all the mid to big servers that is completely independent from the actual cores of your server. And it's remote controlled. You can control it through like different protocols. And aside from allowing you to reboot the machine, it allows you to monitor temperatures, voltage, and fans. So in a way, every time you buy a server, you have, before going into that, this is a graph of how a BMC website looks like. As you can see, it's a beautiful graph with all the different sensors in there that tell you exactly the temperature in different places, how the fans are working, etc., etc. But the interesting thing about BMCs is like, you have a computer inside a computer. You have like a little micro, which generally is like very old micro, inside a huge server that has an independent operating system. So it's kind of like a computer inside a computer. And if you have like a very offensive mind, kind of like hacker's mind, you're thinking about like, this is sound a little bit interesting of like what you could potentially do. Now, let's add the following. It has a full network stack. So obviously you need to be able to connect to this micro remotely, to a BMC remotely. It also has KVM, which means keyboard, video, and mouse into the actual server. And also a serial console, like a direct serial console to the actual machine, and obviously power management. I mean, like you can reboot at any time. You can actually install remotely the operating system of the machine. So that's basically, just kill me, man. Anyway, that's basically a trap, right? It's a perfect background because you have a little micro that you can control remotely and has direct access to your server. That, to me, is one of the perfect backdoor. As my meme will kill it, like people will be like, servers aren't bootable. This is not the perfect backdoor because if the server is off, it's not bootable, right? It isn't. Well, actually, it's kind of like yes and no, because these devices works as far as there is a plug in the server. Even if you turn off the server and it's completely off, like the fans are not working, nothing's working, the BMC are still working. Why? Because the whole concept of the BMC is that you can remotely turn on the machine, right? So the BMC is working all the time as far as there is electricity in the machine. It's not enough to turn off, and there is no way to turn off, as far as I know. This is sort of the architecture of the BMC with the different buses connected to the different places in the server. I'm not gonna go through that because it's a little messy, but I'm gonna tell you a little bit of our research. So every big manufacturer has their own version of a BMC. Maybe for those who work in computers in general, will find those names familiar. So Dell has the iDRAC, HP has the ILO, and Lenovo has the IMM. So the first thing we did when we started doing this research, and again, started reading a lot of information, was to figure out which, because the idea was we need to find rarities on this thing. So we started to dig into what sort of technology was behind those BMCs. And we start with the ILO2. The reason why we start with the ILO2 is because our client has a lot of these ILOs too. Again, this is from HP. It was quite interesting because it was using a micro called NetV850. This is a micro that DVD players and CD players are used. So you can imagine they're not very fast. So research on these things is quite annoying. But the assembly was pretty nice in my experience. And it was using this operating system called ThreadX, which there is almost no information at all. It's a runtime operating system, that's all we know. So when we started digging into that, because it was our first target, we thought once we are done with that, we can move into ILO 4, which is the last version, which is what we were looking for after that, and it's going to be everything smooth and beautiful, and we already have all the knowledge that we learned on ILO 2, on ILO 4. Turned out that when they do ILO 4, they completely change everything. They change the processor, which is an ARM instead of the NEC, and obviously they change the operating system. This is again another runtime operating system, but it's a completely different operating system. So everything that we have researched for ILO 2 was completely lost. We have to start again. Again, for each of those things, we have only 3 weeks, only 2 people. So we have to, deal with our time the best as possible. Then we went into the iDRAC and the IMM. Both were running a micro called Super H. If you are in very old gaming, the Super H was used by Sega Saturn very long time ago, and I think there's some real arcades that actually use Super H too. But likely it was using Linux. It was using a PC box. So it was not once you get in, you have a full Linux, and especially once you extract the firmware, instead of having one huge binary as the other ones, we have actually a file system that you can go and inspect different binaries by itself. So our objective was to find an entity that was pre-authentication and it was remote. This is not simple. If someone told you have to do that on Windows, that's going to mean that you're just going to spend 3 years researching. Because I don't even remember the last time there was a Windows remote without authentication. Probably less. It's going to take a lot of time. But the important thing here is that since this was an embedded devices, there is almost no information about people actually researching or finding vulnerabilities on this. We have high hopes. But I don't have audio on the machine right now. But the interesting thing about or not interesting thing is that BMCs are very loud because basically the server belongs into a data center. It doesn't belong in your home. It doesn't belong in your office. And this video without audio makes no sense. But if you were actually hearing the audio, you will listen to a very, very loud fans running nonstop. And that was 3 weeks multiplied by 4. There was a lot of days of like very loud research. Oops. All right. So since we have a limited time, the first thing we decided to do is once we have set up the environment, have ready enough, was let's put together an attack surface that's going to be common among them, among all of them. And the idea was that let's do a lot of different protocols that everyone has in common, so we have understand the protocol, so we can learn and test on the 4 different environments, of different BMC that we have in place. And this is what we came up with. These are like 4 plus other different small protocols that we're using. There are way more. Each one has their own unique implementation of their own thing, because as usual, manufacturers don't talk between each other, they hate each other, so there's no like standard. There's some external organization that pretend to do a standard but nobody care about them. Sort of like Microsoft in the 2000, where like they will implement their own version of their own protocols. So it was annoying. But at least we were able to find some sort of like common sense between them. And this is sort of like the common sense we have between them. The first one we analyzed was Smash, which is basically a command line interface on top of SSH. Since SSH is not an easy thing to attack, and most of the SSH code was based on open source library, we thought that we shouldn't get into that. That's going to take a lot of our time. However, the interesting thing about the SSH is that if you're able to compromise, then you are inside the machine, or inside the BMC, and when you're inside the BMC, you can actually debug future attacks. So we thought that a little post-authentication reality might be useful for setting up a correct environment. Sometimes you find bugs not because it's your objective, but rather to get into your objective. So this is how it looked like. The interesting thing about Smash is like, if you have the username and password, and trust me, as usual, there's a lot of default username and password, what you get is a telnet connections, or SSL, that allow you to get direct access to serial. So you are doing SSH, you connect there, you make the machine reboot, you have serial access, so you can like, sort of like press S12 or del, and it actually opens the boot loader, the BIOS. And what you see there is sort of like the BIOS menu that you're running remotely through the BMC. And a lot of them allow remote installs through serial. It's crazy. And as you can see, there's a lot of default username that if you're doing a penetration test, you should always test for. Now, the other thing I would look for was SMP. Everyone has an SMP, and what happened was that, again, all the SMP that we're using was open source, so we decided not to go against that. But most of them were vulnerable to very old SMP bugs. Obviously, we want to find ours. We're not like planning to like just say, oh, this is vulnerable to like DCB or US to go and find our own vulnerabilities. But we find out that most of them were vulnerable to this SMP vulnerability. We reported, they fixed it, but it was kind of like curious that a lot of them has the same version of SMP running. The other thing that was very interesting was that, and this is sort of like, if you're doing penetration, you should always do that, is that if you run a SM walk to understand what is SMP providing with a public account, you'll find a little information. But if you go and extract the MIB file from the actual firmware, you will be able to extract way more information. As you can see, the SMP was sharing basically a PS, a list of processes. They were sharing a lot of like different information about connections. It was quite interesting, the things that it allowed you to do. And this is basically not what we're looking for. But this information will allow us, if you don't have access to the operating system, because that's the thing. You never have access to the operating system. You have access to their web console, to the Smash console, but you don't have access to the operating system. But if you want to have a little bit of a look of what's going on behind it, you can do it through SMP. Again, this is setting up the environment somehow, like finding vulnerabilities that will allow you to set up the environment. This is one of the most amazing surprises that we had when we were doing this research. So There's this have you ever guys heard about the APMI protocol? All right. And if you heard about that, you know it's extremely valuable.
Never used it.
Yeah. Turned out that a lot of people had it by default, and we were like, I mean, the manufacturer allow you to disable it, but by default is there. And we asked the manufacturer, like when we presented, and they say that there's certain software that depends on APMI, and that's why it cannot disable by default. So let me tell you about APMI. First of all, it's a UDP protocol. It's run on port 1623. Again, it's helping you a lot to do many things. It allows you to remotely manage the BMC. It allows you to monitor things, get the voltage, fans, temperature, all of that. It also allows you to get a serial console over UDP. This is one of the weird things about UDP. But come with me. Turned out that when we were doing this research, and I never heard of APMI before. This IT War magazine called it the most dangerous protocol in the world. And we were like, this magazine, they're always like trying to pretend that everything is the worst protocol in the world, like this is a war machine war. They're always trying to scare people out. But what we figured out was that they were not actually scared. First of all, there were like 3 vulnerabilities that were already there and been there for years. One of them is that they have this, I think, authentication bypass on Cipher 0. So it turned out that one of the things they had is, so you can connect using different ciphers, right? The first cipher, the Cipher 0, was connect without authentication at all. So you just do like connect with Cipher 0, you're connected, there's no username password, that's it. Okay. After like a couple of years, they disable it, it's not there anymore. Then there was the rugby authentication button. And this is hilarious. Let me see if I have a slide over that. No, I don't have a slide. So, and this is a vulnerability that is not fixed, because when they tried to fix it, the people from the APMI said, this is part of the design of the vulnerability. So it turned out that one of them, as I said before, they use different authentication mechanism, protocol, etc. One of them was called RAKP. And what happened is that there is a handshake going on, right? And you say like, my username is administrator, and they send you information back, and you send some information, and then at some point you have to create a hash of your password with some content and send it back to them. But what we realized, and the funny thing is like we found out, like this is weird, but then we Googled about it, and people already found out about that, is that at some point during that handshake, somehow the server said, I'm going to hash that with the password and send it to you. You're like, why? Like, you only send the username, and they decide to hash something with the password and send it back to you. You're like, why are you doing that? Turn out you can, run hashcatenating, and like after a couple of hours, you got the password. So if you ever see a UDP port 623 nowadays, there's no fix for that. So if you can find out the username of that, you can obtain a hash and then run it through Hashcat and get the password out of it. And it's not hard to do it. And after we realized that, we started using it on our penetration tests on different companies, and it's everywhere. It's like if you're doing an internal penetration test, externally it's really hard to find UDP open, 623 open. But if you're doing an internal penetration test, you will figure out that it's going to be around all the time. Once you get there, again, you're able to access the BMC. That was hilarious. So we started doing our own research. So now we find a little vulnerability. It was sort of like a pool overflow vulnerability. Really hard to exploit it, probably impossible. As you can see there, message length is something you can control. So if you make it less than 6, or less than 5 actually, less than 5, then what happens is like length is going to turn into like a big number, because like -c, it's going to be a negative number. Length turn out it's going to be a huge number. Pool allocates a fixed size, and then when it does an memcopy, the memcopy will just override that pool. So that's obviously it ends up in a pool overflow, do an underflow, integral underflow. Not easy to trigger, not easy to exploit, takes a lot of work to exploit it. Then we went to HTTPS. That was our next target. And obviously, if you're actually attacking the server itself, most of them were using open source servers. So again, we didn't want to get into that because that's going to take a lot of time. But and most of them are using this well-known web server called APP Web. However, some of them implement their own web server, and when you hear like someone is implementing their web server, you know there's going to be vulnerabilities in there. The first thing that we figured out is that there are certain scripts or certain BMCs that will give you information that is very interesting. In those cases, for example, on the ILO and the iDRAC, the ILO has this XML data, and the iDRAC has this CGI being discovered. These provide you a lot of information remotely without obligation. And this, for targeting, is very important, because if you have the right firmware version, as you can see here, then if you write an exploit, that will allow you to do a lot of different things. Especially because these devices have no protection, not any of the modern protection like AL, SR, DEP, and all of that, nothing is there. So if you can exactly point out which is the firmware, then you can target it, and it's going to be a perfect exploit because you will know exactly where everything is allocated, and it's going to work. So we start looking at it, but before we do that, it was funny because when we're doing this research, and we were like, nobody's looking at BMC. This is crazy. Like, I'm sure there's going to be a lot of vulnerabilities. As soon as we were like finishing the first part of our research, which was the ILO2, this team from France find a vulnerability on the ILO4. And as you can see, the vulnerability is pretty simple. It's basically a scanf. Nowadays, you hardly see a vulnerability through a scanf because it's obviously a major vulnerability. It was a Stack Overflow. The interesting part about that, and the reason why we're talking about, is that the way they exploit it is extremely intelligent. So obviously, as Stack Overflows, you can overflow the stack until you override the return pointer, and then you have to do magic, put your shuttle somewhere, jump into that. A lot of like exploit technicality that is not the objective of that. But what this guy did was, they did a small overflow that the overflow turned out overriding one variable that was the one that decided if the query from the server is coming from local or from remote. So what happened in BMC is that everything that's coming from local, I mean from the same server, from the server to the BMC, for them it's something you trust, because like you're already on the server, you can trust the BMC. Now again, that's not smart, but that was their thing. So what they did is like, they modified that variable through that series of 8 that are set in there, which is actually where the vulnerability was. So instead of like creating a complex Stack Overflow, they just create a connection with a lot of 8 and actually do a query to add a user. So in general, that will fail because like you're not authenticating and you're doing that remotely. But since you override this variable and things that's coming from a local connection, then it's like, yeah, you don't need an application. Just add the user and it works, and it's beautiful. This is a vulnerability that we find on the iDRAC. This is quite interesting. So it's sort of like an old school vulnerability. So what's fun here is like we were looking at the iDRAC, and the iDRAC is a busy box, so sort of like a Linux. And what we find out is like we have multiple CGIs running, but it turned out that the parameters, if you send parameters over a GET request, those parameters will be transformed into environment variables, and then it will run the CGI beam. That's the way like CGI beam used to work. And this is a vulnerability that happens like 50 years ago, and then it went dormant because like everyone fixed it. But it turned out like iDRAC just bring it back. I don't know how they did. They were able to like bring this old vulnerability back, but they did. So what we did is like in this case, it's a good way to test if the vulnerability is there or not. Just do an LD debug files, and then what will happen is that it will show you debug information about the actual CGI that you're running. Now, the trick here is to do LD preload, and actually instead of like running some internal dynamic library, you will try somehow to upload a binary into the machine, and then you end up executing it. So, in general, the attack here, what they do is you point it out to the FD0, because the FD0 in general in CGI beans, it's connected to the content of the body of the get. But in this case, this was not working. So what we have to do is we have to do a little bit more research and look at the other CGI beans that were there and find out which one allow us to write some content inside the machine. Now, it turned out that this put file CGI, if you send with certain commands, it allows us to write up to 128 kilobytes into this specific file. So what we did again is upload a CGI file with our own content, our own shared library, and then what we did was to do an LD preload that will load that into our CGI bean, and then boom, we have a shell. And the interesting thing about that is like there's no overflow, so there's no way that we could have somehow break it. So let me see if this works. Hopefully it will. And this is a demo. This is a product that we have to do penetration tests. So what we're doing here is, before I even start with that, what you see here is a node. Like this is Canvas. It's a penetration testing tool that we use at Works that we have built. This box over here is a node. A node represents a machine. In this case, the red one, the local node, is our own machine. What we're going to do is we're going to try to target a remote machine. So we call the exploit. What we're doing is trying to set up a connect port back to us. So you actually connect. So we're running the exploit now. The first thing it does is upload this binary of us into that file in the temp folder, and then it actually do the LD preload to the CGI bean. And what will happen is that now what we will get, hopefully, is another node. Now that node that we have there is the unit shell node, which means it's the node on the BMC itself. So now we're running commands. Like first command is like where we are, what's the name of the host name, and the interesting thing is coming right now. I hope you guys are able to read it from there. We run an ID, and then boom, it's root, because the web service runs as root, because like nobody cares about security on embedded devices. Anyway, so like it's not that it's easy to exploit, it's also giving you like root right away. Like, you don't have to work at all. So the other thing that we look for is like what other things are running on top of the web server that we can potentially attack. And so we look at this web service management protocol that was originally built by Microsoft, so there's a lot of support. It's support on PowerShell by default. So it's quite interesting. It's basically some sort of like SOAP protocol that they use. And we start looking at it. There's two brands of it. You can either see it in an endpoint under /WSMan, or sometimes it's running standalone on a specific port, which is 5985. In general, it's used different sort of authentication, basic out, digit out, Kerberos, whatever. In this case, it had no authentication. The authentication was built inside the WSMan itself, in the case of the IDO that we're looking at. However, we find out that when we started researching, a lot of the vulnerabilities that we found were like from the 80s, because they were so old that we were like extremely surprised about them. So the first one we found was another scanf. Remember that the French team finds scanf in the other form, where we find sort of like a similar vulnerability on this protocol. They were trying to parse an XML, and somehow at some point they used that scanf, normal Stack Overflow. Not as easily exploited as the French team, but it's exploitable. And this is how you trigger it. If you want to try it at home, I'm going to put the slides somewhere. There's another one that I found was very similar, but instead of parsing specifically the XML tag like the other one, it was parsing the namespace of the XML. that same kind of mistake. And I'm sure it's going to be way more. Again, we spent like 3 weeks per BMC, so I'm sure there's a lot more learning. And again, this is how you trigger if you want to do it at home. So let me tell you one last thing, but I only have like 10 minutes. This is like a brochure from some company explaining how BMC works. As you can see, the network admin is connected through the internet directly to a BMC. No, never do that. Never ever do that. Now, what we find is that it's quite interesting. So this is how generally like a network works in relation with BMC. So what you're seeing there is like a server connected through internet. And whatever it is, like a web server on a company. And then that web server then has their own BMC. And then each BMC on an isolated network is generally called out-of-band network. IT people generally have their own like out-of-band network outside of any other network, because that's where like all the IT people connect and remove the machines. This is completely isolated, only IT people have access to that. But the interesting part is that in that network, there's a lot of BMCs. There are all the BMCs now. And so what happened in this case, and what we end up calling, let me see if I have a slide for that. Yeah, multidimensional movement, is that what happened is if you compromise the server, you can move to the BMC. Once you have on the BMC, then you can try to attack other BMCs, as I showed. I show you an exploit for the IL4. I show you an exploit for the LIDRA. And there are more exploits for other different type of BMCs. So now, if you somehow are able to get into a server, then what you're doing is you're moving from one network to the other. So you get into internet through like a web server or anything, whatever it is, you compromise the server. From the server, compromising the BMC is not complicated because it's supposed to be like that. Server and BMC have a trust between each other because they are the same thing. Exactly, sort of like, they're not the same thing, of course, but they trust each other for whatever reason. They're trying to change that, but nowadays, that's how they work. So from the server to the BMC, you can get access to it. Even like you can run certain vulnerabilities to actually get access to the underlying BMC. You can run the same vulnerabilities that we show you from the server to the BMC, because you can create your own virtual network just between the server and the BMC. Now, you compromise the server, you get into the BMC. With the exploit I show you, you move to the different BMCs. Now, once you are in one of those BMCs, you can compromise the server. Because remember, the whole idea of the BMC is that you somehow are able to control the server. You can even like reboot it and boot it with like virtual CD. That's something that allows it. Like BMC has virtual CDs, which basically allow you to mount a remote ISO and boot the server with your own ISO. So now you, from this BMC feed, now you're in the server. And now you're in a network that you're not supposed to be in any way. So somehow, through the out-of-band network, you're connecting and doing not lateral movement, but like multi-dimensional movement, because like you're moving between different networks through another network, like several networks. That's kind of like what I explained. Now, the other thing I was missing when we did all this work was how do we persist? Like, once we compromise the machine, how can we continue being on that machine? Turned out it was kind of incredible. So we tried on the iRack. The iRack was running Linux. So we look at what was mounted on that machine. Turned out there is a flash read and writable that mounts most of the configuration files that you modify when you are configuring your own BMC. One of the configurations was a Chrome file. So once we were able to compromise a BMC, we just changed the cron to point out to a binary that we upload. So now we have access to the BMC, even if the machine is rebooted, even if the machine is turned off. The funny thing is that we try to upgrade to a new firmware to see if like our persistent backdoor was removed. It was not. You upgrade the firmware and your binary will still be on that flash. the cron will continue to be like that. So turn out like it's sort of like impossible to remove backdoor unless you actually have operating system access to that BMC. And that's something that manufacturer doesn't offer at all. So like if you're able to compromise the BMC, nobody will take you out of that. There's no antivirus for BMCs or nothing like that. So and again, you make the backdoor in the BMC, the server cannot detect you, and you can compromise the server as many times as you want. So it's sort of like the perfect backdoor. Well, finally, as I said before, there was a lot of things that we have to do more research. One of them is DMA. I know the French team was able to find on IL4 DMA. DMA means sort of like direct memory access from the BMC to the server, so they can inject things to the server while the operating system is running. That's pretty cool, and they were able to compromise the server that way. Then there was exploit that we didn't finish, and also there's so many other proprietary protocols that requires analyzing, like they have their own like BMC sort of protocol that we're sure is updated and have their own vulnerabilities, so that's kind of amazing. And there are other protocols themselves that are pretty interesting that we were not able to cover, and I'm sure they're full of bugs. So again, if you want us to move into the research, BMC are definitely the way to go. Conclusion, you should panic. There's definitely, these BMCs are terrible. What we usually recommend when like people came to us and like, how do we fix that? The only thing that we recommend is like, try to maintain it isolated from each other. If you have an outbound network, just try that those BMCs cannot see between each other. So at least there's no like lateral movement going on in there. But other than that, you can complain with the manufacturer, but there's no way to isolate it at all, unless you disconnect it. And then again, you have to drive to the data center and have to reboot yourself when nobody wants that. So that's it. Thank you very much. And if you have got questions.